Okay, hello everybody, Simon here. I promised I would go through a pen and paper approach to the week 10 in-class task. So here we are. Let's see if I can do it in 20 minutes with a nice explanation and, give you some good example of how you should approach questions in the exam coming up. So to start off with, lab 5, the list intersection question. So in this question, you are given a struct node, which is used to represent a linked list. We should all be very familiar with old linked lists and data structures, and most people did pretty well in this question, which I really liked. So in our node structure, we've got it's a node. We've got a pointer to some data. It's void star. We don't really care about what it is, and we've got a struct node pointer to the next node, and then we can close that off with a simple. So that's what we're opening with, is what we have. I don't expect you to write this in a question. I'm just writing it so we have something to look at and talk about. And we're given a nice example here, which is A points to, one of circles actually, B points to D, and there's a C here, which also points to D. And we are asked, your task is to count the number of nodes that are shared between two linked lists, right? And we're saying, with this example, given A and, that should be A and C as inputs, given A and C as inputs here, we should return 1, because D is the only node in the intersection, right? And it says specifically, note that the data of the node is unimportant, right? Where we really care about which actual nodes, which pointers align with each other. That's what we're interested in. So we're asked to implement a function, which is int. So just in here, A and C should give 1, which refers to D. So we're asked to implement the function int intersection underscore size, and we get struct node star left underscore head, and we get struct node star right underscore head. So given two linked lists, basically, we want to make a function that counts the size of the intersection. Now, empty lists are considered valid, and we are told we may create utility functions as we need, and that we don't need to worry about having the correct include headers. And the hint for this was to think of an example with more than one intersecting node first. So in order to think about that, let's just think, how would we extend this example to add more intersecting nodes? The logical thought to me is that you just add more nodes onto D. Add an E. Now the intersection of each list is of size 2. Add an F, right? And thinking about this a little more, we sort of quickly realize that this is the only kind of intersection that we can have. We can't, for instance, if I move down, we can't have some nodes that, go on for a little while in two lists, and then eventually they join in a node, and this is in the intersection, and then they separate again. That's not possible. We can't have one list that goes like this way and another that goes this way, because this node here can only have a pointer to one next. So basically, what we've been asked to do is find a point where two lists merge and then count the length of the rest of the list, which is basically how I've implemented my code. So the way I've thought about it as a logical problem-solving thing is a rough pseudo code type of thing. I want to up here. I want to find if/where two lists join, and then I want to count length from then on. A lot of people didn't do the count length. They just counted all the places where each list joined, which is completely valid and fine. It just makes, I think it doesn't actually make your code much neater. It just arguably makes it a bit less efficient. It'd be more n squared. Both would be O n squared ultimately, but mine is arguably slightly quicker, and I think it's nicer to think about. So that's what I'm going to do. So what I did for a utility function was I had a quick one, which I think works as a nice warm-up as well, is to have a list size function given a struct node star list. Okay, and this function, basically I want to have a counter, and I want to loop through and count every node that happens, which should be a pretty simple pattern that a lot of people have seen before. So I would say struct node current, my cursor is going to equal list. I'm going to set an int count to be 0, and then basically while current is not equal to null, that's in brackets, I want to do count plus plus. So if my current node is valid, I'll count it, and then I'll move on to the next node. Current equals current dot next. A few people used list size functions in various ways in these questions, and a lot of people were looping while current next is not null, which makes sense if you want to find the end of the list. You want to go until you're at the last node and the next one isn't null. But here you want to make sure you count every single part of the list. So you want to be looping over current. And once current's null, you don't actually care about finding the end of the list. You never have to use the end of the list. You just want to make sure that you visit every node. So if you keep going until current.next is non-null, you'll end without actually counting current, if that makes sense. Okay, so, and then at the end of this, I just return count. Okay, and this is just a pretty regular list traversal type of structure. So in terms of our intersection size here, we'll just do int intersection underscore size, and why not, let's copy out the whole struct node star left underscore head and struct node star right underscore head. I'm not too fussed about handwriting because you guys know what I'm referring to. You can see the rough idea. And let's have our curly brackets. So what I want to do is, my first thought, to find that intersection point and then afterwards count the ultimate size of it, is to loop through the left list, and for each node in the left list, loop through the right list and see if we find a match. Okay, if you look on Ed and you see the solution I've typed up, which should be probably directly above this little video that I've linked in, you'll kind of see that that's basically what I've done. So general idea when you want to loop through a list is just above near struct node star, and it's going to be the left cursor for looping, or left current for looping through the left head, left underscore head. And again, I want to make sure I check every single node, and I don't care about storing the last node. So I'm going to do while here left underscore current, and let's be really explicit, not equal to null. That's my thought. Okay, so having that, right, I'm going to do a bunch of stuff. Let me count how many lines, so it comes up neat. 1, 2, 3, 4, 5, 6, 7, 8. So about down here, I want to do my little, like, reassign my cursor. So left underscore current. At the end, of course, we need to map it to left underscore current next. Like our little, it's kind of like a for loop. Well, really it is a for loop, but doesn't matter. And at the end is an edge case. Like, imagine we're given null as a list here. Left current will be null straight away. So then we'll exit straight away. So as my edge case, when one of the lists is empty, I want to return 0 straight away. Or if we get through the whole list and we never find any matches. So basically, I then want to take another copy of this code and put it inside to loop through the right list, so that I can, for every node in the left list, loop through the right list. So I'm going to do struct node star right underscore cursor, and I'm going to say that equals right underscore head. And you can sort of see here that, like, this little block is a loop through the left, and I'm going to have another block in here, which is a loop through the right. Yeah, that works out. Okay, so struct node left current is, no, sorry, right current is right head, and then just, you know, the old while right underscore current is non-null, plonk, plonk, plonk. and that's going to close down here. Inside, right at the bottom, I'm going to put right current equals right current or cursor next. Loop it to the next one. And then you're going to ask, what am I going to do in this little thing here? Basically, I want to check if my cursors match each other. So if right current is equal to left current, and if that's true, I want to return for my whole function. Remember before, we want to return the size of the list from this point on. So I'll just return list underscore size of, it doesn't matter which one, but let's just do left current. And that's it. That's my code. And we kind of know here that if these two are both null, we'll never get into this edge case, so we don't have to worry about list size being passed a null. But also up here, it is passed. It does handle passing a null correctly. It returns 0. So even if we somehow manage to glitch into there, that'd be okay. And in terms of correctness, there's just, we loop through the right nodes out here. Inside, we loop through the left nodes on the outside. And for each left node, we're looping through the right node. So for each possible pair of nodes, we're checking for the same. A lot of people, instead, in here, they had some kind of like counter ++. That also works. There is a potential thing that, especially if you're in an exam situation, you're quite stressed, you might worry about double counting. But that shouldn't be a big worry here. It turns out like it is actually okay. Like when I first think of something like that, I'm like, oh, would I be double counting with my multiple loops? But it's actually fine because you're only incrementing one at a time. Anyway, so that is the function that I had together, and I'll just finish it off with my nice little curly bracket down the bottom there. And that's the solution you'll see. As perhaps some general advice about these questions, you'll notice that it's been about 12 minutes for me to fully explain this and go through all the details. If I slot back down here, get rid of some of the excess paper. We come back here and we'll just talk about it for a second. So first thing I did was look at the structure that I had been given and then think about some examples and try to understand it clearly. That's a good process. It's always worth it to put that bit of thought in and try and make sure it's clear to you first. Because once you do that, and you're familiar with some of the idioms of like, oh, how do you loop through a list? Well, you just do while your cursor is not null and blah, blah, blah. Once you get those idioms, it becomes quite easy to translate a good understanding into code. What I see a lot of people doing is they see a code question and they jump straight into trying to write some code. And maybe sometimes that can be useful if you're going to write a small function that you're confident on how you're going to write and that you're probably going to need it. You can do that as a little warm-up. But in principle, I would say think about it and get a really clear idea of what you need to do and how you're going to do it conceptually and translate that clear idea into code once you've got it. I know 20 minutes doesn't seem like a lot of time, but 20 minutes hacking away trying to figure out how to make your code work, that is not a lot of time. But 20 minutes to sit and think of an answer and then translate it to code as a two-step process is much more doable. So as a main takeaway, I would say like 1, think, and then 2, translate. And then, of course, if you have a little bit of extra time, 3, double check it. Anyway, that's been me. Yeah, I hope you enjoyed the lab exercise as best you could and the unit and things. And yeah, if you're looking for exam study, I'd recommend having a go at Lab 7's question. That's my other class. They had a similar kind of question to handle, and I'll also have a video up of me going through the answer to that one so you can think it through and try some of the other lab questions. They're all on vaguely linked lists, so it's not all the content you're going to cover, but the approach is quite relevant to the exam. Anyway, thank you. Best of luck for your exams, and good night.